In this section, we're looking at Newton's method. And in example 1, you're approximating the zeros using Newton's method. And in this tutorial, you'll learn how to use your calculator, and specifically the entry key, to have the calculator do most of the work for you, not only with Newton's method, but technically with any iteration. And if you need a definition of iteration, just scroll back up the screen and read that it's basically any function where the next value is based on the value before it. So let's start by entering that expression into our calculator. And again, this is in example 1 in lesson 7, section 3.8. It says to enter the expression as one line on your calculator, and be sure to use the negative sign for the actual values of negative numbers, not the minus sign. So let's enter in negative 0.5 minus parentheses 0.5 parentheses negative 0.5 cubed plus negative 0.5 squared minus 5 times negative 0.5 minus 3 close parentheses divided by parentheses 1.5 times negative 0.5 squared plus 2 times negative 0.5 minus 5 close parentheses. Now take a moment to look this over to make sure that you've entered in everything exactly as it appears. It's important that the beginning and ending parentheses of the numerator and denominator are present, so it will calculate the numerator and denominator separately, then do the division. It's also important that you have the parentheses in the correct places before you take it to the exponent, because we're taking a negative value to a power. On the outside of the parentheses, it'll include that negative. If you put it on the inside of the parentheses, it wouldn't. So again, make sure that it appears exactly as it does here. Now once you've done that, hit enter. You should get that negative 0.555555556 value. Now it says for it to be accurate to no less accuracy than the thousands place. So we want it the same to the 10,000ths place. Now how we can have our calculator do most of the work for us, this was our first guess, the negative 0.5. Using Newton's method, we got this value. So hit second enter. Now any place you have a negative 0.5, which was our first guess, let's go back and let's enter in this first value from the first iteration, our second guess per se. Go to second, and then just above the negative sign is answer. We want to replace the negative 0.5 with answer, so hit answer. Now we'll need to delete this extra stuff here. Now do the same thing for every one of the negative 0.5s. So put in second answer, delete the rest of the 0.5, go to the next one, second answer, delete, 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 and do this for all of the negative 0.5s. And again, it's important that you get rid of all that extra stuff. And don't replace anything else either. Just replace the negative 0.5s. Now after all that, hit enter. Now, we don't have to enter in all this again. Since the answer is already in there, every time we hit enter, it's going to be using the answer from the previous iteration. So hit enter again, and we're already to the needed accuracy. If you notice, with this iteration, so our approximation of the second zero using this method in our calculator would be negative 0.5554. And it's that simple. Put in the original expression, replace your first guess with answer by going to second and then the negative sign. It has the answer right above it. Hit enter to get the next iteration, and then continue hitting enter until you have the desired accuracy.